Class. In this video, we are going to review Grade 5, Unit 5, Place Value Patterns and Decimal Operations. In this unit, we learn about place values, numbers to the thousands. For example, we learn ordering, comparing, rounding decimals, expressing them in an expanded notation. We learned about adding and subtracting decimals, multiplying them, and also dividing decimals. Okay, so let's start with expressing decimals in words and expanded notation. So the first thing we need to remember is about our place values. So here, for example, we have, this is the decimal point, right? And the decimal point, what it does is divides the whole numbers from the fractions. So here we have the hundreds, regular hundreds, right? The tens place, the ones place, and then you have the decimal point, and then you have the tens, that's 1 out of 10, the hundreds, 1 out of 100, and then the thousands, 1 out of 1,000. So, for example, this number right here, 1.321. If we were to express that as in words, that would be 1 and 321 thousandths. So notice how the last digit tells us how we should end our words here for the number, because this is the thousands place, the last digit here in this case. All right, so let's talk about expanded notation. When you multiply each digit by its place value, that is expanded notation. So let's take a look at this number here. This number is 32n. Notice how the decimal point means n. So 32n 542 thousandths. 32 and 542 thousandths. Okay, so this 3 here is in the tens place. So in expanded notation, that part is going to be, you have 3 groups of 10, or 3 copies of 10, because this is in the tens place. So 3 times 10. Then this 2 in the pink here is 2 in the ones place. So we say 2 times 1. Okay, so now we have the decimal point. Now this 5 is in the tens place. So that means you have 5 groups of tens of 1 out of 10. And this 4 here is in the hundredths place. So that means that you have 4 groups of 1/100th. And this 2 here is in the thousandths place. So that means you have 2 groups of 1,000ths. So in this number, in expanded notation, is going to be 3 times 10 plus 2 times 1 plus 5 times 1 out of 10 plus 4 times 1 out of 100 plus 2 times 1 out of 1,000. Sometimes you can also write this portion here as 5 times 0.1, because 0.1 also means 1/10. In this part, you can also write it as 4 times 0.01, because that means 1/100th. And this part here, you can also write it as 0.001, because that means 1 out of 1,000, 1,000ths. So that is another way to write this. Okay, so next, let's do one example. Let's express 15.094 in words and expanded notation. So you may pause the video now and try to do this yourself, and then check your answers together with me. Okay, so now give it a try. All right, so now let's check our answers together. So let's express it in words first. So we have this 15. So we're gonna say 15. All right, so 15. All right, so we have this part, right? 15. Now the decimal point, we're gonna say n. 15n. And here we have we have 0 in the tens place. So that means we can just skip that part. So that'll be 94. So 94. All right, so 94. Okay, so we're gonna go with the last place value here, and this 4 is in the thousands place. So we're gonna say 15n 94 thousands. All right, 94 thousands. Okay, so now let's spread that in expanded notation. All right, so let's start with this digit here in the 1. This 1 here. This 1 here, we know that it's in the tens place. Okay, so these are our place values. So here, this is the tens place. So this is the tens place. Here is the ones place. This 0 here, this is the tens place, the 1 out of 10. This 9 right here is in the hundreds place. And this 4 right here is in the thousands place. Thousands. So 1 out of 1,000. Okay, so let's keep that in mind. So this 1, we have 1 times, well, that's a tens place, so 1 times 10. 1 times 10. Plus, so we're done with that digit. The next digit is in the ones place, and we have 5 of them. So that's going to be 5 times 1. Okay. Let me see what is the next digit. Okay. So now we're going to the decimals now. So here we have 0 tenths. So you can skip that. You know, I don't mind if you can also write 0 times 1 out of 10. That's acceptable too. But you can also just you can just skip that part if you want. I'm just gonna skip it for now, but it's also okay if you write 0 times 1 out of 10. Okay, so let's go ahead to the next digit. That's gonna be the 9, and that 9, it's in the hundreds place. So that's gonna be 9 times 1 out of 100. Plus, and now we have the 4, our last digit here, which is in the thousands place. So it's gonna be 4 times 1 out of 1,000. Okay, so this is expanded notation. So 15n 94 thousandths in words and expanded notation. All right, so the next thing we learn is rounding decimals. So let's remember the instructions on how to round decimals. So step 1 is to identify the place value you are rounding to. Step 2, look next door. 5 or more, raise the score. 4 or less, let it rest. So these are the rules that we're going to follow to round these decimals. Okay, so what is 1 and 578 thousandths? 1.578 rounded to the nearest hundredths. Okay, so step 1, identify the place value you are rounding to. So let's identify the hundredths place. So go to the hundreds place. So this is the ones, this is the tens, this is the hundreds. So identify the hundreds place right here. And now that also means that our answers are going to go only up to the hundreds place. Because when we round decimals, we are simplifying them. We are simplifying them up to the hundreds place. So step 2, look next door. 5 or more, raise the score. 4 or less, let it rest. So I'm going to look next door right here to this 8 here. And I notice that it's 5 or more. So that means I want to raise a score. So this 7 in the hundreds place is going to become an 8. So this number rounded to the nearest hundredth is going to be 1.58. Okay? Because what we're really saying is this number, is it closer to 1.57 or is it closer to 1.58? And it's obviously closer to 1.58 because we look next door and that's an 8 there. Because the 5 kind of tells you whether it's more than half or less than half over here. If you're closer to the top or closer to the bottom, closer to 1.58 or closer to 1.57. So you're closer to 1.58. Okay, let's do the next one. What is the same number here? 1 and 578 thousandths rounded to the nearest tenth. So step 1, identify the tenths place. This is a tenths place, this 5 here. Look next door. 5 or more, raise your score. So in this case, we got 5 or more because there's a 7 there. Okay, so that means that this is going to round to 1.6. Remember that our answer is only going to go up to the tenths place. Everything else, we don't want. We want to simplify our answer to the tenths place. Okay, next, what is 1.578 rounded to the nearest whole number? All right, so pause the video and try it out for yourself. Okay, so first let's identify the whole number. When they say the nearest whole number means the number that is over here, behind the decimal here. This is the whole number. This 1 right here, 1 whole. So is this number closer to 1 whole or is it closer to 2 wholes? Is it closer to 1 or closer to 2? Okay, so we're gonna look next door. And I see a 5 there. So because it's 5 or more, we're gonna raise the score. So this 1.578 rounded to the nearest whole number is 2. Okay. Now let's talk about adding and subtracting decimals. How do you add and subtract decimals? Okay, well, you're going to, step 1, very, very important, is to line up the decimal points. Because if you line up the decimal points, you're going to be able to match each digit according to place value. Step 2 is to add zeros as placeholders to make the numbers the same length. But by the way, that is optional. But that will help you. It will make it easier for you. And step 3 is to just add or subtract as normal. Okay, so let's go ahead and let's do the first one here. Okay, so we got 517 and 5/10 plus 4 and 67 hundredths. Okay, so let me do, so we're gonna line up the numbers for the decimal points. Okay, this is our decimal point right here. So 517.5 And now we are going to line up the other number here according to the decimal point. So let's line up that decimal point first. We have to line up that decimal point. Put a 4 right here. Okay, and the 6, 7 goes right here. 6, 7. All right, so notice how we lined up our decimal points, and that helps us line everything else up. The ones to the ones, the tens to the tens, the hundreds to the hundreds. Well, over here you have no hundreds. So like I said before, you can fill this up with zeros. That's if you want to. Okay, so let's just, these are zeros that you can add here just as placeholders so you don't get confused. Okay, this is optional. Okay, so now all we have to do is just start doing our adding. So we got nothing here plus 7, it's still 7, 0 plus 7. Okay, so we got 5 and 6, that's 11. So put the 1, carry the 1. We have to bring down our decimal points. Everything has to be lined up. Okay, so now we got 7, 8, and 4. Okay, that's going to be 12. Put the 2 here, carry that 1 here. Okay, 1, 2, that's going to be 2, and 5, and nothing here, that's still 5. So I have the answer as 522 and 17 hundredths. Okay, very good. Then now let's do this subtraction now. Again, the first thing that we're going to do is that we are going to line up the numbers according to the decimal points. Okay, so we're going to do 84 and 29 hundredths minus, okay, let's line up our decimal points, 26 and 8 tenths. So the tens to the tens, the ones to the ones, and the tens to the tens here. So we are subtracting. And here we can add zeros as a placeholder here. Okay, so all right, so we got 9 minus 0, that is still 9. All right, 2 minus 8, we can't do that, so we have to go in this door. Okay, so this becomes a 3. And now this, every time we borrow, we're borrowing a 10. So now this over here is going to become a 12. Okay, so now we got 12 minus 8, and that's 4. So now we're going to bring down this decimal point. Okay, so now we got 3 minus 6. We can't do that. So we have to borrow from over here. So this becomes a 7. And every time you borrow, you're really borrowing 10. So this is going to be 13. Okay, so now we got 13 minus 6. That's going to be 7. Now we got 7 minus 2. That's going to be 5. So the answer here is going to be 57 and 49 hundredths. All right, very good. Okay, the next thing we learn is multiplying decimals. So how do you multiply decimals? So step 1 is to multiply as if there are no decimal points. And then the next step is that you're going to count the total number of decimal places in the factors. Then you're going to place the decimal points in the product so that it has the same number of decimal places. I'll show you how to do that right now. Okay, so let's multiply this, imagining there are no decimal points. Okay, so I think we all know that 4 times 7 is 28. Okay, so this is going to be 28. Okay, so So we did that. We multiply as if there are no decimal points. Next, we are going to count the total number of decimal places in the factors. Then place the decimal point in the product so that it has the same number of decimal places. So let me go over here and let me count the total number of decimal places in the factors. So in this factor, there are no decimal places over here. There's no decimal point. There's a whole number. But in this factor, I have one decimal place right here. Let me circle it, 1. So that means I'm going to place that back over here one time. I'm going to scoop it up like this, scoop it back like this, 1, and put that decimal point right there. So the answer is going to be 2.8, 2 8/10. Okay, let's do the next one. Okay, so the next one, we got 6 wholes times 4 hundredths. Okay, so again, step 1, you're just going to multiply it as if there were no decimal points there. So we're going to multiply 6 times 4. And we know that 6 times 4 is going to be 24. 24. So now, what you're going to do is that you're going to count the number of decimal places in the factors. So in this factor, there are none because it's a whole number. But in this factor, you have 1 and 2. So you're gonna move 2 decimal places over here. 1, 2. So that means that the decimal point goes right here. So the answer is gonna be 0.24, 24 hundredths. Okay, now let's check out this one now. Now you give it a try. Pause the video and try C and D here. 5/10 times 6/10 and 3 6/10 times 8/10. Okay, so we got I hope you tried it. I hope that you paused the video and tried it out for yourself. Let's go over it now. So you got 5/10 times 6/10. So again, first just multiply it, imagining there are no decimals. So 5 times 6 is 30. Okay, next, we're going to count the decimal places in each factor. So let's go to this factor here, and we have 1 decimal place. Let's go to the next one. We have 1 decimal place. So that's 1, 2. So we're going to do the same thing over here. 1, 2. So that means that the answer is going to be 30 hundredths, 0.30, or 0.3. It's the same thing. 3/10 is the same as 30 hundredths. All right. If you haven't paused the video yet to try the next one, I urge you to do it now. Okay, so we got 3.6 times 0.8. So what we're going to do is that we're just going to multiply it normally. Okay, so I'm just going to multiply 36 times 8. Okay, so I know that 8 times 6 is 48. So I'm going to put the 8 here. And I'm going to carry the 4. And 8 times 3 is going to be 24. Plus the 4 is going to be 28. Okay, so I have 288. But of course, that's not our final answer because we have to place back the decimal. So let's go ahead and count the number of places here. The number of decimal places in each factor. So I have 1 decimal place over here, and I have another decimal place over here. So I have 1, 2. So I'm going to go to my answer and go 1, 2. So my decimal point goes right here, such that the answer is 2 and 88 hundredths. So 2.88 is our final answer. Okay, I hope you were able to understand that. Next, we learned about dividing decimals using an algorithm. So what is this algorithm? So step one is to ask yourself, is the divisor a whole number? Very, very important. Is the divisor a whole number? Because if it's not, then we have to convert it to a whole number by multiplying it by a power of 10. But whatever you do to the divisor, you must do to the dividend. Whatever you do to one side, you have to do to the other side. Just like in fractions, whatever you do to the numerator, you have to do to the denominator. Okay? So step two is to perform the division as you would with whole numbers. And step three is to place a decimal point in the quotient in the answer on the top, directly above where it appears in the dividend. We'll see some examples now. Okay? And then we just continue dividing as usual. So let's do the first one. So we got 2 divided by 1/10. Okay, so this right here is my divisor. This is the number doing the dividing. So we got 0.1 into 2. Okay, so step one, is the divisor a whole number? Well, the divisor here is not a whole number. So that means that I have to multiply it by a power of 10. Okay, so multiplying by a power of 10 just means scooping it like this. So if you do it one time, that is like multiplying it times 10. So I'm doing times 10. And of course, the decimal in a whole number is actually like, there's an invisible decimal right here to the right of it. Okay. And so this decimal place is right here, and you're going to scoop it up one time too. It's like multiplying 2 by 10. So 2 times 10. So now this is going to become a new problem now. Okay. This is going to become 1. So this became a whole number 1 into, well, 20. So we all know how many times 1 goes into 20 because we know that 1 times 20 is 20. So the answer is, of course, 20. Okay. Now, let's give this one a try. We got 9/10 divided by 6. Okay. So this time, we the whole our divisor is a whole number. Remember, the divisor is the second number here. So we got 6 into 0.9. Okay, so we're gonna bring up this decimal point right here. Okay, and I already know that 6 goes into 0 times, so I'm just gonna put a 0 here, and I'm just gonna go ahead and start with the 9 here. So I'm gonna ask myself, how many times does 6 go into 9? And 6 goes into 9 only one time. Only one time. And 6 and times 1 is gonna be 6. Just line up everything. Okay, so 9 minus 6. Okay, that's gonna be 3. Oh, hold on. Okay, so now we cannot have a remainder when we are dividing decimals. Okay, so the trick is that we can add as many zeros as we want over here. Okay, let's add this 0 right here. We can add as many zeros as you want over here. So we have to bring it down, bring down that 0. Okay, so now we got 30 here. So now we can ask ourselves, how many times does 6 go into 30? And we all know that 6 times 5 is 30. Okay, so it's 30 here. We got the 0. So our answer is 1500s. 0.15. 1500s. Okay. Let's do the next example. So we got 846 divided by 2 hundredths. So in this case, our divisor here is 200. So we got 0.02 into 846. Okay, so this needs to become a whole number here. So in order for this to become a whole number, we need to move our decimal point twice. Let me see, 1, 2. So that means you are multiplying it by the power of 10. In this case, 100, because so we got 2 hundredths, and we need 1, 2. So times 100, and whatever you do to this side, you have to do to this side. So this side is also going to be times 100, and we are moving the decimal place that is invisibly over here, 1, 2. So we're going to add 2 zeros here also, like this. And the decimal place is not going to be over here. Okay? So this is going to become 2. Just write it over here. So I need some space. 2 into 846 times 100. Times 100. So 2 more zeros. Okay. So, well, this division is pretty easy. If you just can understand that 2 goes into 8 4 times, 2 goes into 4 2 times, 2 goes into 6 3 times, 2 goes into 0 0 times, and 2 goes into 0 0 times. So the answer is going to be 42,300. So, but let me just show you the algorithm. All right, so we're going to ask ourselves, how many times does 2 goes into 8? That's going to be 4 times. 2 times 4 is 8. Okay, 0. So bring it down. Bring down the next digit. We got 4. Okay, how many times does 2 go into 4? 2 times. 4 times 2 is 4. Okay, that's 0. Bring down the next digit. Okay, how many times does 2 goes into 6? 3 times. 2 times 3 is 6. We got 0. Bring down the next digit. 0. How many times does 2 goes into 0? 0 times. 2 times 0 is 0. 0 minus 0 is 0. Bring down the next digit. 0. How many times does 2 go into 0? 0 times. 2 times 0 is 0. We finally did resolve all the way up to the last digit, because we have to work with all the digits, just like we did here. This is the standard algorithm for division. So the answer for this is going to be 42,300. Okay, so that is how many times 846 goes into 2 hundredths. Okay, is there a different way to do this? Yes, and in the Illustrative Math curriculum, most of the time we saw it like this, not with the standard algorithm. So dividing decimals using decimal grids and common sense about place value. So here we got 2 into, how many times does 2 go into 1/10. So just using common sense, we know that one goes into 1/10 exactly 10 times. So how many times is 2 gonna go into 1/10? Well, if you know that 1 goes into 1/10 10 times, then 2 into 1/10 has to go in 20 times. So that will be your answer, 20. And if you want to see it in the decimal grids, then you're going to go ahead and you're going to divide these two holes, one hole here and one hole here, into tens. So you have 1/10 over here. That's 1/10. You have another 10th and another 10th, another one, another one, another one, another one, another one, another one. So all of these are tenths. And if you go ahead and just divide all of them and you count them, you are going to get exactly 20 of them. And you can use different colors for each so that you can differentiate between each. For example, like this. Let's say I use green for this one. For this 10th. I use green for this 10, just so it's easier to count this way. So I'm separating the groups more easily because these are groups of 1/10, right? So we want to know how many groups are in total. All right, I hope you guys get the point here. It's kind of tedious to cut all of this. Just want to show you guys here. Okay. Okay, so now we can count. We just divided two holes into tens. So now let's count it. You're gonna go ahead and count it. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Just like we said over here, 20. And just like you saw before in the standard algorithm. Okay, how about this problem here? You got 9 tenths divided by 6. Okay. So the first thing you're going to do is you're going to shade in 9 tenths. Okay, so you know that each long strip here is going to be a tenth, right? So you got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it goes up to here. Okay. So I already know that I cannot divide this equally into 6 parts. So I cannot go 1, 2, 3, 4, 5, 6. I cannot do that. So, but I do know that I can get exactly equal groups of 1/10 or 10 hundredths here. So let me go ahead and separate these. Okay. So here I have one group over here. One. Let me color it different. Blue. 1, 2. Oops. 3. 4. 5. And 6. So I have 1, 2, 3, 4, 5, 6. So I have 6 equal groups, but I still have to add this portion to them. So far each group is composed of 1/10. Okay, so far. But now I need to see how many I have left here. And if I count each one or each row, I have 30 hundreds. Each of these is 100, so I have 30 hundreds. And if I divide this evenly into 6 groups, because I know that 30 divided by 6 is 5, I know that it's going to end up to be exactly 5, and you can prove that easily. Let's say we get 1, 2, 3, 4, 5 here, and now we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let me just separate this part here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So I have 5, 10, 15, 20, 25, 30. 30 hundreds left. And each one is going to get plus 5. So you have 10 hundreds plus 5 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 hundreds plus 5. So each group has exactly 10 hundreds plus, so let me just add a 0 here, 10 hundreds plus 5 hundreds, okay? And that is exactly 1500. So the answer is going to be 1500s. Okay, so now this one, how can we solve this one using common sense? Well, we know that, so this number is 846 divided by 2 hundredths. So we know that one whole, so that's 846 whole divided into 2 hundredths. We know that one whole divided by, 100, 0.1, right? Because that's one whole, for example, here, and each little box, each little square is 1 out of 100. 1 divided by 100 is 100. It's 100. So 1 divided by 200 is going to be half of that. It's going to be 50. Okay, so let's keep that in mind, that 1 divided by 200 is 50. So what is 846 divided by 200? Okay, so if 1 divided by 200 is 50, then if I want to find out what 846 divided by 200 is, all I have to do is multiply 846 times 50. Where did I get this 50 from? From here, because I know that 1 divided by 200 is 50. So to figure this out, I'm just going to multiply 846 times 50. And to make it easier on myself, I'm just going to multiply 846 times 5, and then I'm just going to add the 0 at the end. So let me go ahead and do that. 846 times 5. Okay, so we got 6 times 5 is 30. Just carry that 3. 4 times 5 is 20 plus a 3 is 23. Okay, so we got 5 times 8. Okay, that's going to be 40 plus a 2 is going to be 42. Okay, so now all I have to do is, because it's not times 5, it's times 50. So let me go ahead and just add that 0, because when you multiply something by 10, you just add in a 0. So let me add the 0. So now let me add the 0 here, so you see it. So this is my final answer. Okay, 42,300. Just the same answer that we got before when we use the standard algorithm right here. 42,300. 42,300. So just using common sense, using grids, you can also do like this too. All right, I know this video was long. I hope you learned from it. I'll see you in the next one.